I'm Palak.
Hi, I'm Amrita.
Hi, I'm Supriya. Our project is on 6LoWPAN network for IoT sensors.
IoT is the recent trend of connecting everyday devices to the internet. Consider an IoT device like a sensor which can sense temperature, pressure, humidity, etc. These sensors should be connected to the internet through a router. In such a network of sensors, if any of the sensor is far from the router, it cannot be connected to the internet. We can overcome this drawback by connecting the sensors in a mesh network. Here the sensors are connected to each other and in turn to the router through the sensors.
So this is our system architecture. We have a mesh network of sensors which runs 6LoWPAN protocol and hence IPv6 addressing. This network has to be connected to the internet which runs internet protocol. Hence we need an edge router to interface the 6LoWPAN network to the internet.
Our system is divided into 4 modules.
First is the mesh network, second slip radio, third edge router, and fourth is the integration of these modules.
Texas Instruments SensorTag is by default Bluetooth enabled. We have reconfigured it to a 6LoWPAN network by building it on Contiki, and the generated executable file is flashed onto the SensorTag with the Smart RF Flash Programmer and XDS110 dev pack. Our second module is the slip radio. Slip is serial line IP and it is an RF interface between the edge router and the mesh network. We are using Texas Instruments CC2531 dongle for this purpose. It supports IEEE 802.15.4 and Zigbee application. Using Smart RF Flash Programmer and CC Debugger, we have flashed it with the slip radio application provided by Texas Instruments onto it to act as an RF interface to the 6LoWPAN network.
The third module is the edge router. We are using Raspberry Pi as an edge router. In order to configure this as an edge router, we are using an open source application called 6LPR.
6LPR basically stands for 6LoWPAN border router. As shown in the diagram, it is used to interface the wireless sensor network running on 802.15.4 to the IP network via Ethernet.
This is our setup. These are the sensor tags. And this is Raspberry Pi on which 6LPR has been configured. This is the CC2531 dongle, which is the RF interface, and Raspberry Pi has been connected to the laptop for the power up, and the LAN cable has been connected to the laptop because Ethernet is required. We have started the 6LPR application on the Raspberry Pi. Once the application has been started successfully, we can access the default web server page. On the system tab, we can get the network statistics, and when we go to the sensor tab, we can get the sensor informations which are connected to the router, and this is a notary which depicts the network diagram. This is the sensor page, and we can go to this web page of that particular sensor, and once we land on the page, we get the parameters that the sensor is sensing, like temperature, light, pressure, etc.
With this, our system will overcome the issue of a far-flung sensor. In this system, the sensors not only sense the data but also route the data of other sensors to the main router. Therefore, with our architecture, IoT can be implemented in large areas and even in areas with poor internet connectivity.